guys, it's Brittany and welcome back to ISYE 3770. It's probability and statistics. And today we're going to be talking more about standardizing the normal random variable, specifically in terms of binomial and Poisson. And so we talked about standardizing the normal random variable in a previous problem when you're given the normal distribution. And recall that we represent this by using a z value. So when we can basically say that z is equal to some value of x minus the mean, which is mu, all over the standard deviation. And so this is for the normal distribution. We talked about this in a previous video where the notation is a big letter n, and you're given the mean and the variance, which is our sigma squared. And so this is for standardizing the normal random variable in a normal distribution. We can think about this as a Gaussian distribution. And so how do we standardize the normal random variable for a binomial distribution? Well, we can still use the same letter z. Z is equal to, again, some value of x minus, and instead of mean this time, we're given the binomial distribution, so it'll be actually n times p all over our standard deviation, which is n times p times 1 minus p, all square rooted. And we can recall that a mean for a binomial distribution is n times p, and that the variance for a binomial distribution is n times p times 1 minus p. So if that's our variance, to find our standard deviation, we need to square root it. And that's our binomial for us, or that's how we standardize the normal random variable for a binomial. So for Poisson, we're also going to convert this back and forth between our letter z. And we also have some value of x minus our lambda all over our standard deviation for a Poisson distribution, which is the square root of lambda. And this is where lambda is greater than 5. On a separate topic, we can talk about normal approximation. And this is also known as continuity correction. And so with normal approximation, we can approximate the probability of our random variable x in some kind of like error bars where we have like an amount of space for correction within what this random variable, what its value actually is. And so we can say that the probability for some random variable x being less than or equal to some value x, we can account for continuity correction by rewriting this into saying that the probability of our random variable x is less than or equal to x plus our continuity correction value of 0.5. Similarly, for values where the probability of our random variable x is greater than or equal to some little x, we can rewrite this accounting for our continuity correction by saying that the probability of our random variable x is greater than or equal to x minus 0.5. And so an example of this let's just say that we're trying to find some Poisson distribution where the probability of x, some random variable x, is less than or equal to, 900. And so say like we were given some abstract problem and this is what we break it down into from words into, the probability that we're trying to find. And so we can look back at our normal approximation rules and see that this is where the random variable is less than or equal to some value. So we're actually going to add 0.5 as our continuity correction to whatever our value is. So in this case, it's 900. And so here we'll just rewrite this by accounting for a normal approximation, say that the probability of x is less than or equal to 900 plus 0.5, which is 900.5. And if we want to rewrite this, let's just say it's like a Poisson problem, and that we want to find like this probability. Well, we can rewrite this by saying that the probability of some value z, so we convert our random variable into the standardized version, which is z, which we can eventually use to look at like z tables in those charts to find the probability So we can say that our value z, when we convert it to standardized, is less than or equal to, and then our Poisson value of z, which will be 900.5 minus our lambda all over our standard deviation for a Poisson distribution, which is just our lambda square rooted. And whatever this solution is, that'll be your answer for the probability accounting for normal approximation that our random variable x is less than or equal to our value 900. And that's all for today. Hope y'all enjoyed a quick little video on standardizing the normal random variable for binomial and Poisson distributions, as well as a quick overview on normal approximation. And I hope to see you next time. Bye!